Now, the last time we did identifying the equation for graphs, I think we overlooked one of the problems. We overlooked the easiest one, which was the linear function. This one right here, we did not do it. Or did we? Did we do it? We did not, right? That's what I thought. So let's go ahead and identify this equation. So it's on page 7. We had overlooked it in our last recording. Now we have a straight line. Now the only thing you need to know for the straight line to write the equation is the slope and the y-intercept. Because remember that y is equal to mx plus b. Right, y is equal to mx plus b. So if you can identify the m, which is the slope, and the b, which is your y-intercept, then you can just write the equation. Now, can you identify what b is, where this graph cuts your y-axis? At 1. So right away you know that your b is 1. Now, what is your slope? And by the way, this is a decreasing line. Can you all see that? So your slope is going to be negative. So once it's falling, you're going to have a negative rate of change. Negative 2 over 3. How did you identify that? Very good. Very good. So remember that your slope is rise over run. So all you can do is, let's create a triangle. So that has a rise of 2, and then just do the run for it. The run would have been 3. So it's negative 2 over 3. So just create a right angle triangle and do rise over run. And so what is our equation? Y equals? Negative 2/3 x plus 1. Very good. So for the lines, that's how you do them. Very easy. Identify the slope, the y-intercept, and then you are good to go. Now we're moving on to 1.4. Which is the graph of absolute value of a function. Now, when we talk about the absolute value of a function, or absolute value in general, you're looking at distance. All right? And what do we know about distance? Can distance be negative? Can I have negative 2.5 miles? No, in reality, that doesn't exist, right? Right. So to show you what we're doing here before I look at the notation formally, let's say we have a number line. So I'm going to have 0 here. Then we have 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. And let's say I go from 1 to 4. So that's 1, that's 2, that's 3, that's 4. What's the distance of this line? What is it? 3, very good. So what we're going to say is that the absolute value would be equal to 3. Very good. Now let's look over here to see what's happening. Let's use a different color. Let's say I go from negative 1 to 4. What's the distance of this line? All right, so we're on the negative axis, right? So that's why we're going to say the absolute value. The distance is still going to be 3. Right? So the distance is always positive. So we say the absolute value of -3 would still be 3. So always remember that. And that's why this is your definition for the absolute value. So it's going to equal to f of x whenever f of x is greater than or equal to 0, meaning 0 or positive. And then negative f of x if f of x is less than 0. And this is the reason why, let's say f of x in this case is -3, you would have negative 3, which eventually give you a positive 3, because it must always be positive. Does that make sense? So with that being said, we can look at a more formal definition. Let's say we have something like this. I'm trying to find space, guys, sorry. All right, example, let's say we have something like this. The absolute value of x is equal to 3. In that case, what are the possible values of x? What can x be? Or? Very good. So if the absolute value of x is equal to 3, this simply means that x could be +3 or x could be -3. Because whether it's a negative or a positive, it's still going to produce the same result as 3. And you're going to need to remember this concept when we actually solve these equations. You're going to have two possibilities, right? You're going to set one to the positive, one to the negative, and then you solve. And do you understand why x can either be 3 or -3? Right, it's because, remember, just like what we have here, it doesn't matter which is inside the absolute value, is going to produce a positive answer. Right, so it could either be positive or -3. So these will always have two possibilities when you solve them. But before we look at those, let us go ahead and examine some problems relating to the graph of the absolute value function. And then we can look at solving some equations afterwards. Now, in this particular case, we are given the graph y equal to f of x. And we know that this is a squaring function that they are transforming, right? This is your f of x right here. And they want us to find the graph of the absolute value of f of x. What do you think we're going to do? Nale, you were saying something? No, go ahead and say. You're partially correct. Anybody else want to try? And what will that do to the y value? So whether x is negative or positive, what should happen to the y? Which is? Positive, right. So it means that all your function values must be positive, because whether x is negative or x is positive, it should give you a positive y result. Because the absolute value, remember, when you solve it, you're always going to get a positive. So all we're going to do, so make a note here, don't forget, you're going to change all negative y coordinates to positive. So we're going to change all negative y coordinates to positive. So let's go ahead and label some points on our graph. So we have this point right here, this point, and I'm just using the whole number ones. And if y is already positive, it stays the same. That doesn't change. right? If y is already positive, you don't change it. Just change the negative y to positive. So what's happening here? At this point, we have -6, -3. What should it be? -6, +3, right? So that's where it will go. Now, this point here will not change because we don't have negative or positive 0. 0 is just neutral. So this doesn't change. This also does not change because y is already positive. This also does not change. And what happens to this one here? We have 2, -3. What does it become? 2, +3. And then go ahead and draw your graph. And this now is going to be the graph of y equal to the absolute value of f of x. So all we did is we changed all the negative y coordinates to positive. That's all you do to get your new graph. All right, next example. Let's look at this one. So we're given f of x, and we are asked to find the absolute value. So here again, we're going to do the same thing. So will this point here change? Because y is already positive, good. What about this point right here? Will it change? No, that doesn't change. What about this point here? -1, -2. What does it change to? -1, +2, right here. So my new graph, I'm using red, so we don't confuse it with the old points. So just remember that -1, -2 will become -1, +2, because the y must be positive. What about this point here? Does it change? This does not change. That remains the same. What about this point right here? Does it change? No, it doesn't. And I think we have enough points now to draw the graph. So it's going to look like this in red. Then we're going to go up, down again to meet this one, and then like that. And that's what your new function will look like. So let's get the main points on the graph and then change all negative y to positive. Positive y values do not change, they remain the same. Moving on. By the way, this is not your assignment due date. Yours is on your updated guides. So let me just erase it so nobody think that their assignment is due in February. All right, so this is what we have right here now. So we are given this function. They want us to sketch it. And then they want us to determine the domain and range of the function and also the absolute value function as well. So what I'm going to do is we're going to sketch the original function first. And then we're going to do the absolute value to make life a little easier for us. All right, so let's go ahead and sketch this function. What would this function look like? So we have an absolute value function that is shifted over how many units? 2 units to the left And then what?
2 down.
And then 2 down. And then what does this negative tell you? It's reflected or flipped. Very good. So remember your absolute value function, guys. We're going to shift over. So this means left 2. So all the beautiful things you learned in 2.3, they're coming back. So you're going to go left 2. You know, we're going to flip. And then we're going to go down 2 to get the original, and then we can do the absolute value afterwards. All right, so let's go over. Left 2 would land me here, and then I'm going down 2, so right here. And the fact that it is flipped, instead of going up, we are going to be going down, right? So these are your points. Go ahead and draw it. Notice I did mine 1 to 1. Anybody can tell me why? Because there is no stretch, right? And you all know why I turn it like this, because it's flipped, right? So all you have to do now, everybody, is just to, so this is your original function. So this is the f of x. Now to get the absolute value, we're going to change all negative y to positive. So let's label the point with a different color, so you can see exactly what's happening. I'm going to use black. All right, so these are the points that we have. So -2 is at -2. Where should it be for the absolute value? Very good. So right here. And you don't even have to try to flip the others. It's very easy. You know that it's going to be like this because it's right. There's no stretch.
So I meet with Charlotte around like.
So this now is the absolute value of f of x. So all of these negative y values, you just change them to positive. That's all I did. So here we have -3, 3 is going to be -3, +3. Where you have -4, -4 is going to be -4, +4. So all negative y becomes a positive. Now, let's answer some questions. What is the domain of f of x, meaning the original function? What's your domain? Very good. -infinity to +infinity. What's the domain for the absolute value function? This one up here? Same thing. And notice there's no break, so it's valid for all x values. So that's from -infinity to +infinity. Now, what is the range of f of x, meaning the original function? Right, we start with the lowest. So notice y, so it's from -infinity. But where does it stop? Right here at -2. Parentheses or square bracket? Square bracket, because we're including this point here. It's not a whole there. What about the range of your absolute value function? Where does it go from? Very good. Notice it starts at 2 and then it goes upward all the way to infinity. And by looking at the range of the original function, remember all you're going to do is change all negative to positive. So that's what you would have. All right, I'm gonna give you all a minute to try this one. So you're given the original function. So you're gonna sketch the absolute value function and then find the domain and the range. All right, so this is your original function. So it doesn't continue on and on. So before we draw the absolute, let's just find the domain and range of the original. What's the domain? Look where x spans from. Where does x start? -3. And where does x end? 2. So it means that the domain for the original function is going from -3 to 2. Because it doesn't go on and on to negative infinity to positive infinity. It stops somewhere. You all see that? Right. Now, what about the range? You're going to look, where does it start on the y? Look, just draw your line here. Where does it start? -2. And where does it end? Right here at 2. That's for the original, right? Now let us draw the absolute value function. Will this point change? All right, will this point change? All right, so these remain the same. Will this point change here?
Yes.
Why? We don't have -0. So this will remain the same right here. What about this one down here?
That one.
Yeah, this one will change. So 2 -2 will become 2, 2. And then this is your new graph for the absolute value. All right. Now, did the domain change? X still go from that to right. So it's from -3 to 2. What about the range? That will change. Where does it go from now? On the y, 0 to 0 to 2. And that's how you do it.
So when you're given the equation,
Yes.
you have to graph it like for the one before. You're given the,
This one right here?
yeah.
Right. So the one that they give you is the original f of x. But you now would have to draw your own absolute value, meaning you change all negative y to positive and get your new values.
And like the other one that we did before,
Mhm.
it has the equation f of x equals -x + 2 and all that.
Right.
So when you're given that, you have to graph it on your own.
Yes. So in a case like this now, you would have to graph, because they didn't give us the original, right? So you'd have to graph that on your own and then graph the absolute value as well to get the domain and the range. Right. I mean, you can get the domain and the range without graphing, but it takes more algebra. So I think the easiest thing to do is to graph it.
Yeah.
And I'm also going to show you on your graphing calculator how you can graph absolute value functions. So you can always use that to check your results as well. But you must know how to do them manually as well, right? And normally for your exams, I usually give the graph for the most part. Most of them you'll get the graph and you'll do work from that. But I think there may be 1 or 2 where you will have to graph yourself. And you are allowed to use your calculator in the test. So you can always sketch it on your device to make sure, that what you did is correct. So it's not going to be overly difficult. All right, let's continue now. Now we're going to look at some algebraic ways in which we can solve our absolute value equations. And then we're going to be using our graphing calculator to support our answers. So when you get these on your homework or your test, do not just plug them in the graphing calculator and say, here is the answer, sir. No, you need to solve them. And then you can graph it for your own benefit to check if your result is correct or not. So let's go ahead and solve. Now, remember earlier I told you that when you solve an absolute value equation, there are 2 possibilities. So let me remind you. So if we have the absolute value of x is equal to 3, it means that x can be +3 or x can be -3. Always remember that there are 2 possibilities. So likewise, in this case, when I get these to solve, you're going to have 2 possibilities just the same. What's the first possibility here? you're gonna take negative 3x minus 9, set it equal to 6. That's the first possibility. And the second possibility, we're gonna take negative 3x minus 9 and set that equal to negative 6. So one possibility is positive, one is negative, and then we're going to solve. Because remember, we look at the number line, whether it's on the positive side or the negative side, the absolute value, the length will always be positive. So whether it's negative or positive inside the absolute value, it will produce the same positive result. So always remember, guys, two possibilities. I cannot emphasize it enough. People always just do one and then get half of the credit on exams. It's two possibilities. Now let's go ahead and solve. Go ahead and solve this. We're going to have negative 3x equal to, what happens if I bring this over? And what's that? Yeah, so what's 6 plus 9? 15. What do I do next? Divide both sides by?
3.
Negative 3. And so x is equal to? Negative 5. No, that's one answer. Let's look at the other possibility that x can be. We're going to have negative 3x is equal to negative 6 plus 9. So negative 3x is equal to 3. Very good. If we divide both sides by negative 3, what do we get? X equal to negative 1. So what we're saying is that x can either be negative 3, negative 5, sorry, or negative 1. So if you plug negative 5 or negative 1 into this, you're going to get the same 6. Let's test it and see. What's negative 3 times negative 5? Right, 15 minus 9. See, you get the same thing on the other side. Now let's test when it's negative 1. What's negative 3 times negative 1? Negative 3, no, positive 3. And then 3 minus 9 gives us? Negative 6. But because it's inside the absolute value, just like here, what happens? It's just going to be 6.
So on equations like that, to have both options, you just flip the last number to a negative?
So one is positive, one is negative, and then you solve.
Okay.
Right. Always. There will always be two possibilities. I remember we looked at it earlier when I showed you the number line. So whether you're on the negative side or the positive side of your number line, the distance is always positive. You don't have negative distance, and that's why you'll always have the two possibilities. Now let's use our TI-84. Let me show you how we can graph these to check our results. So get out your calculators and let's check them. No, you also have the steps. If you look on page 10 on your note-taking guide, you'll see the step. But that's not the step I use. There's an easier way. You can just click on math. Then go over to number and then select the first option. So math, number, and then absolute value. So that's how you can get your absolute value symbol. Is that clear to everybody? Or you can use the second, then 0, and then go to absolute. I think that's more steps, so whichever you prefer. All right, so let's go to y equal, and we're going to graph our original equation. So I'm going to put y1 for the left-hand side. So we need the absolute value, so go to math, number, absolute value. And inside, we want negative 3x minus 9. So that's negative 3x minus 9. And then for y2, you're going to put your right-hand side, which is 6. And then we're going to graph them and find the intersection. So let's go to graph. And if you're not seeing your graph, you can always increase your window values.
Yeah, mine says quit.
All right, so for those of you, if you're not seeing your graph, it could be either of two things. You need to change your window values or you need to turn your stat plot off. So to turn the stat plot off, go to second and then y equal and make sure that the stat plot is off. So go to stat 1. As you can see, mine is off. If yours is on, turn it off. Right, so turn off, make sure stat plot 1, 2, 3, and 4, make sure they're off. All right, so make sure it's on off and not on. And then go back to graph and you should be able to see your equations. Are you all seeing the equation, the graph?
Let's see the Excel is
All right, so now we're going to calculate the intersection to see what our x values are at those points. So to do that, go to second and then click calculate, which is your trace button. And then go down to number 5 that says intersect. And then just use your cursor. So I'm going to just go to this one first and click enter 3 times. 1, 2, 3. So notice x is -1 when y is 6. So you know that the first option is correct. Then you can do the same thing for the other side. So I'm just gonna quit this and then go back to my graph. And then we're gonna do second, calculate again, intersect. And then this time, this is get it over to the other intersection and hit enter 3 times. And you'll get your result. See, -5. So that will tell you that both your responses are correct. All right, so please remember, guys, whenever you solve these problems, you always have 2 possibilities. Set 1 to the positive, 1 to the negative, and then you solve. Always remember, otherwise you're only gonna get half the credit if you only solve 1 possibility. You have to solve both. All right, now let's look at when we have a greater than problem, how we do this. Now, when you have a greater than problem, for example, in this case, we're going to have -3x minus 9 is greater than or equal to 6. That's your first possibility, that doesn't change. So notice the first possibility is always the given without the absolute value. And the second possibility, now what do you guys think is going to be? -3x minus 9 is what? Very good. Less than or equal to -6. All right, so change it to a negative and flip the sign. Yep. And for greater than, we use or. We always use or. Don't forget that. When it's greater than or equal to, we use or. Do not forget that. How we're saying that it can be this or it can be this. Now let's go ahead and solve. So this would be -3x is greater than or equal to what? 6 plus 9? 15. Now divide both sides by -3. What do we get? Right, x. And what happens when we divide throughout by a negative for your inequalities? You all remember what happens? You flip the inequality sign, so this becomes less than or equal to negative 5. Yes.
Is that a less than or equal to on the far right? Or
Yes. Reason being for this one, you have to flip the inequality sign to get the second possibility. And it's coming from the fact that when you divide by a negative, you have to flip your inequality sign. Now, remember that from inequalities? Right. All right, so x is less than or equal to 5. Or, let's solve this side over here now. Let's see what we get. Negative 3x minus 9 is less than or equal to, what's negative 6 plus 9? 3. Now divide both sides by negative 3. What happens now? X is greater than or equal to negative. Negative 1, right? No, you're good. How can I write my answer in interval notation? So x is less than or equal to negative 5, right? So that means that we're going from outer space. I'm going to put it over here. That means we're going from negative infinity to negative 5. And we're including the negative 5. So we're going to use a square bracket. And then union, that's for or. Right, so union for or. And then greater than or equal to negative 1. So it means that we pick up at negative 1 and then we go to infinity. So that's your final answer if you're asked to write it in interval notation. So always remember that when it's greater than or equal to, you use or, right? So you're going to leave this as the original, where whatever is inside the absolute value is greater than or equal to 6, or the other possibility is going to be flip the inequality sign and change the sign. So less than or equal to negative 6, and then you solve both. That's what we do. Now look at C. When you have a problem like C, this is a less than problem. And the same goes for when it's less than or equal to. Now, when you have a less than problem, you're going to solve it as a 3-part inequality because you're finding the intersection and not the two ends that you're joining, as I said. So in this case, when it's less than, you're going to have negative 3x minus 9 is less than 6. But at the same time, it must be greater than negative 6. So always remember that for your less than problem, solve it as a 3-part inequality. Right? So you keep this as the original, but at the same time, it needs to be greater than negative 6. You can also solve it separately, similarly to the one we did in part B, but you have to use and instead of or, and it matters. So when it's less than, you're saying and that's why we use a 3-part inequality. Don't say or, because or would mean that you're going to be joining two ends of the set. And that only happens when it's a greater than problem. Now let's solve this. Anybody remembers how we solve a 3-part inequality? In this case, we need to add 9 on both sides, right? On all the sides. So we're going to have 3 is greater than negative 3x. 3 is less than negative 3x, which is less than 15. Now divide both sides by negative 3. So what do we have here now? We're going to have negative 1 The fact that we divide by a negative, what happens to your inequality sign? You're going to flip them. So that becomes greater than x, and that becomes greater than -5. Yes.
If it was greater than, would you still have three-part inequality?
No. When it's a greater than problem, you use or, because you're going to end up with joining, right, the two ends of your line. That's basically what's happening. When it's a less than problem, you use a three-part inequality. Now, how can I write this in interval notation? We can flip the order. So we're saying x is greater than -5, right? So we start at -5, but it's less than -1, so we go to -1. You always start with the least value. And if you look back at your graph, you can also check your result. Look at this, everybody. Where is the absolute value less than the line y equals 6? It's in this region here where it's below it. And it's from where? From -5 to -1. You all see that where it's below the graph? Where is it above it? -∞ to -5. And then from -1 to infinity. So you can tell that your results were correct. So for greater than, you look where it's above it. For less than, you look where it's below it. All right, let's do another problem. Whenever you get problems like these, you always want to transpose it before you apply your absolute value definition. So don't just go ahead and set one side to -18 and one side to +18. It will be incorrect. You have to first get rid of everything except your absolute value. What is inside your absolute value? So in this particular case, look at this, guys, we are subtracting 2. So what do I need to do on both sides? Add 2 to both sides first. So we're going to end up with 5 times the absolute value of x plus 3 equal to 20. Now there's something else we need to get rid of. What is that? The 5. Get rid of the 5 first. So we're going to divide both sides by 5. And so we're going to have absolute value of x plus 3 equal to 4. And then now you can apply your absolute value definition. So please remember, guys, I've seen it over the years. Do not go ahead and set one side to +18, one side to -18. Always get it to be the absolute value equal to something before you apply the definition. So now what are we going to have now? What are the two possibilities now?
X plus 3 equals 4 and x plus 3 equals -4.
Who said that? Very, very good. X plus 3 equal to 4, or we have x plus 3 equal to -4. Now go ahead and solve both sides for x and tell me what you get. What's the first value of x? X is equal to? What's 4 minus 3? 1. And what's -4 minus 3? -7. Those are your possibilities. All right, let's look at another example. Now notice here, what do we have here, everybody? This one, it's a less than problem. So what do we use to solve it? three-part inequality. So you're going to say 3x minus 1 is less than 8 and greater than negative 8. So that makes it easier. Now let's solve. How do I solve this? Add 1 to all the sides. What's negative 8 plus 1? Negative 7. Then write back my 3x. 8 plus 1? 9. What do I do now? Divide both sides by 3. Am I going to flip my inequality signs? No, because we're not dividing by a negative. So we're going to have negative 7 over 3 is less than x, which is less than 9 over 3. And you can also put this in interval notation if you want. Negative 7/3 to 9/3. Because sometimes the problem will ask you to write it in interval notation, so get used to it. No, fraction is fine, or decimal, whichever you prefer. But you don't need to go ahead and leave it as a fraction, that's fine. Are we getting the gist of it so far? All right. All right, next problem. Let's look at this one right here, everybody. Absolute value of x minus 4 is less than 0. What do you all think about this problem? Because we don't have negative 0, do we? How would I solve this problem? Or what do you think about the problem? What's that?
It's less than 9. It's less than 0, so it's a bit too.
Let me tell you what they're trying to say here in this case. They're saying the absolute value, which we know that represents length, right? Or distance. They're saying that the length is less than 0. What would that mean? If something is less than 0, what is it? Negative. But can the length be negative? No. So in this case, you have no solution. So when I get a problem like this, do not waste time to try and solve it. The absolute value can never be negative. Length can never be negative. So there's no value of x that you can plug in there to get the absolute value to be a negative value. So look out for those tricks. Another way you could see it, this is another example. Let's say we have absolute value of 2x minus, let's say 3, less than, say, negative 2. So here again, they're saying the absolute value is negative, but less than negative 2 means it's negative. So this is also not possible, so no solution. So anything of that form, don't waste time to solve it. There is no solution. Because length can never be negative. All right, let's look at this one down here now. They're saying the absolute value, but look at this one carefully now. The absolute value is greater than negative 2. What do y'all think? It would be what?
It would be the or, so you just put the greater or less than sign to be like the same one, but 5x minus 7 is less than 2. Wouldn't it still be negative 2 is greater than?
Look at it carefully and see what they're saying. There is a solution for this one.
Can I not solve it like normal?
Kind of what?
Can I not solve it like normal?
No. If you try, you're gonna get into trouble. So if it's greater than a negative, anybody else wants to try? What's happening? No. All right. Yes, go ahead, Nalia. No. Mhm. So what they're saying is that the absolute value is greater than -2. So let me say something to you. Like, for example, if say the value is 0, will 0 always be bigger than -2? Let's say the value is 1. Will 1 be bigger than -2? What about 10?
So
5. So all values, right? So no matter what x is, because remember that this part here is length, right? Think of it as length. Length can either be 0, you cannot have no length, like it doesn't exist, or you can have a value, like whether 1 mile, 2 miles, 3 miles. So no matter what the length is, it has to be bigger than -2. So this is always true. And your answer is going to be from -infinity to +infinity. So any value of x will produce a value that's bigger than a negative when you evaluate the absolute value. So always remember those little shortcuts, it helps. All right, let's look at another situation that you may see. When you have one absolute value equal to another. Anybody has any idea how we can solve these? There are also two possibilities. What do you think is the first one? Very good. So x minus 4 is equal to 7x plus 12, and we're going to solve. That's the first possibility. What's the second possibility? Yeah. So take x minus 4 and set it equal to the negative of this side. So that's negative 7x plus 12. So you're going to set one side to be negative. We have to introduce a negative somewhere. So this one side needs to be negative, and it doesn't matter which side. And then we are going to solve. All right, so let's solve, guys. What are we going to have here now? We're going to have
+4 to the other side.
You want to keep your x's positive or negative? It doesn't matter anyway. So here I'm going to have 7x minus x. I'm going to bring this one over. Then I'm going to bring this over here. So we're going to have -4 minus 12. So negative 16 is equal to, is that 6x? And then divide both sides by 6. And that can be simplified to -8/3. That's negative 2.67 if we round it off. Now let's solve the other side. We're going to have x minus 4 equal, distribute your negative. So this is going to be negative 7x minus 12. And then we're going to solve. All right, so let's solve. So that's going to be x plus 7x equals -12 plus 4. So 8x is equal to -8. And so x is equal to -1. And these are the graphs. I went ahead and did it for you. They're on your note-take-it guides. You can see where the intersections are. -2.67, same thing as -8/3, and then also at -1. And I did 2 pictures so you can see both intersections. All right, so that's how you would do it. And you check your result to make sure it's correct. Now, what if you're asked to solve the graph for f of x greater than g of x? So you're going to look where f is above g. Can you identify where f is above g? By the way, this is your graph of f. This one right here. So you're going to look, where is this graph above the other one? It's going to be over here. Everybody seeing that? So that's to the left of this first intersection. So that's -∞ to -8/3. And then union. Where is it above it? Can you all tell? Where else? All right, where is it? Is it above it? Right here as well. So because there's no gap in it, we don't need to use a union, we could just continue straight. Let's see here. Oh no, actually, over here it's not actually above it. It's below. This one is on top. So it's only in this region here. So it's actually from -8/3 to -1, right? It's only in this region. Sorry about that. Yeah, that's where it's actually above it. Notice this other function is below it. Over here, this is the one above, this is the one above. So it's only in here.
These parentheses, not brackets.
These are parentheses. Do they look like brackets?
No, I was wondering.
Yeah.
Why do
Right, because it says greater than. Right. So if it was greater than or equal to, then you would use bracket, right? All right, guys, so that's what we would have. Now, there are some problems in your books where you have to use a graphical method only to solve it. Anybody has your textbook with them today? All right, so for example, if you look at on page in your textbook, page 131, and then if you look at number, I don't want to do one that is assigned to you for homework. Let me just double check what your homework problems are for 2.4. Yes, so we can do that one. So number 17(9). And it actually states that you have the absolute value of x plus 1 plus the absolute value of x minus 6 is equal to 11. So once you get any of this type, do not try to solve it algebraically. You're gonna solve this type graphically by you're gonna set all of this to y1 and then set this side to y2 and then find your intersections. That's how I want you to do it. Anything of this type. Is that clear to everybody? So on your homework, that's how you would do it, if it's of this type. Yeah, sure. So go to your calculator, go to y equal, and let's clear out what we have there before. And then we're gonna go to absolute value, so math, number, absolute value, and x plus 1. And then go out and put a plus, and then insert another absolute value. And then what's the other one? X minus 6? I think so, right? X minus 6. And then go down, and I think the right-hand side was 11. And then we're going to graph this. And if you're not seeing your intersection, we may need to increase our window values. So I think we need to go up more on the y-axis. As you can see, I'm not seeing my intersection. So I'm going to increase y max to about maybe 25. And then go back to graph. Good, and then calculate your intersections to get your two values. So second, calculate, intersect, hit enter 3 times. So we have -3, and then just go back and do the same thing for the right-hand side. So second quit, go back to your graph, and then just do the same thing for the other intersection. So we go to second, calculate, intersect, and just go all the way over. Sometimes I wish this was a touch screen. It's too much work to be pressing. I think so. And then hit enter 3 times. Right, so the two answers would be -3. So we're going to get x equal to -3 or x equal to 8. And that's how we will do it. Where are you guys packing up? We still have 5 more minutes. So we're moving on to 2.5. Let's at least introduce 2.5 before we go. But this is not bad. So you will have a few of these on your test as well. So you should be able to solve a basic absolute value equation analytically, meaning algebraically, or just plug it into your graph and tell me the result if I ask you to do it graphically. And as I told you before, something like this will be done graphically. But as you can see, I haven't given you a method to solve these. It's way more technical. And even if you use the direct method, it's not going to give you all the possible solutions. So do not ever attempt to use algebraic method to do something like this. When you have two absolute values being added and it's equal to a value, try not to do that. Just use the graphical method. All right, so now we're going to be looking at piecewise functions. Now, when you have a piecewise function, it simply means that the function is defined differently for different values of x. So as you can see here in this particular case, we are told that f of x is equal to x minus 2 whenever x is less than 3. However, when x is greater than or equal to 3, we use this function here, 5 minus x. So what if we're told to find f of -5? Which of those will I use? You're going to ask yourself, -5 would fall, is it less than 3 or is it greater than or equal to 3? So which one do you use? The first one, because -5 is less than 3. So in this case, you're going to plug -5 where the x is. So that's going to be -5 minus 2, which is -7. So the main objective to these is to know which of the piecewise functions to use. -7. Now, f of -1, which of the functions do I use? Is it the first or the second? Why the first one? because -1 is also less than 3. So that's going to be plug -1 where the x is, so -1 minus 2. What does that give us? -3. Now we have f of 0. No, is it the first or the second one? Right, because 0 is also less than 3. So you're looking at the value of x that you're looking at. So you know which function to use. So that's going to be 0 minus 2, which is -2. Then we have f of 3. Which function do I use? The second one. Why? Right. Notice the first one, it says for x less than 3. So anything 3 or more, you can't use the first one. We have to use this one here. So f of 3 would be 5 minus 3. So anywhere the x is, we just put the 3. And then that's just going to be 2. All right, so that's what we would have. And these are pretty straightforward. All you're doing is making a substitution, but it's just for you to identify the value of x and to know which of the piecewise functions that you're going to be using. So they're pretty straightforward. So remember now that we are almost at the end of chapter 2, as you can see. So remember that you need to start preparing for your chapter 2 test. Because once we finish chapter 2, then our next class we're going to have the test. So don't wait for me to say, hey, this is the test date. The fact that we're getting close, you should know that your test is lurking around and you're going to have that pretty soon.